Hello class. In this lecture we will see what is the ideal or the perfect gas law. So there are basically two types of gas are exist in the thermodynamics terms. Okay, the first is the ideal or perfect gas, and the second one is the real gas. So to have a if we talk about a real gas having a undefined behavior, because if we just talk about the air, so air will have a combination of many gases in it, and every gas having their different property. For example, air consists of water stream. Okay, water stream and have some different property. It consists of argon, it कंसिस्ट नाइट्रोजन ऑक्सीजन रहता है, कार्बन डाइऑक्साइड रहता है, कार्बन मोनोऑक्साइड रहता है. सो एयर, जो भी एयर है वो हमारे डिफरेंट डिफरेंट गैसेस का कॉम्बिनेशन है. सो एवरी गैस or each gas having their different property, thermophysical property. So while studying behavior of any system in which that gas is used as a working medium, that time it is very difficult to take care of or to uh, concentrate on behavior of each and every gas on the basis of the thermophysical property. So to make it that study simple, we are um, we are what we can say, we are supposed to study a behavior of ideal gas in that system, and whatever the behavior of ideal gas is approximately matches with that रियल गैस बिहेवियर. बिकॉज रियल गैस में मे बी एनीथिंग. फॉर एग्जाम्पल अगर हम एग्जाम्पल लेते हैं तो इनसाइड द इंजन, ओके, एयर कम्स एंड द फ्यूल कम्स. इट सपोज उसका कंबशन होता है, उसके बाद बनता है स्मोक. स्मोक इज वन ऑफ द गैस विच कंसिस्ट ऑफ कार्बन मोनोऑक्साइड, कार्बन डाइऑक्साइड, नाइट्रोजन ऑक्साइड्स, ओके, sulfur dioxide. So if we talk about, if we want to study that combination of gases, then we have to think on the property of each and every gas which present in that combination. So it will be difficult. Okay, so to have this study very simple, we having some approximation, or we have to make a constant or common thermophysical property as a by relating with the ideal gas. For example, we are not bothered about what are the combination present in that real gas. We are just simply saying this gas is behave as ideal gas. This another thing, it consists number of gases, but we are saying, हम ये बोलेंगे कि वो जो combination of gases है, it's not a combination of gases, it is only one gas having so and so thermophysical property. What is the thermophysical property? Pressure, volume, temperature, okay, specific heat, after that enthalpy, entropy, those all are the thermophysical property. Thermophysical means with respect to the temperature it varies. Okay, so those are the thermophysical property of that gas. So while studying the system, we have, while doing the study of any system, we are studying a behavior of working medium present in that. Okay, on that basis we can suppose to say work done, the amount of work done by the system, amount of work consumed by that system. Okay, so for that purpose we must know the laws of ideal gas. This is a law of ideal gas or the perfect gas which give a approximate behavior of real gas. Okay, so approximation, on the basis of approximation we supposed to study a system. Okay, so now the as a first statement mentioned, it is a hypothetical gas which obeys the law PV is equal to RT at all pressure temperature is called as an ideal gas. So all pressure, volume and temperature condition, those gases obeys a law is equal to law, that is PV is equal to RT, pressure volume multiplication is equal to RT, that is R is nothing but the characteristic gas constant and T is nothing but the temperature of that gas. So जो gas ये law obey करता है at all pressure, temperature and volume condition is called as a ideal gas or the perfect gas. Okay, this law is also called as a state law. Okay, law of state. After that, second statement, ideal or perfect gas is gas which remain gaseous phase at all pressure, temperature and is no perfect. Okay, okay, so what it means, it is such a gas which present in a gaseous form, whether at minus 40 minus 60 degrees Celsius also it will be remain as a gas. It won't condense और it won't crystallize as like ice. जैसे हमें लिक्विड नाइट्रोजन इज अवेलेबल है, जैसे जैसे नाइट्रोजन को कंडेंस किया तो उसका लिक्विड नाइट्रोजन बन जाता है, उस तरीके से ये जो आइडल गैस रहेगा उसको कितना भी कंडेंस करो तो इट वोंट चेंजेस gases to liquid and liquid to crystal. It remains as a gas at all pressure temperature conditions. So such gas is called as the ideal or the perfect gas. And in realistic, no perfect gas or ideal gas is present in a nature. Okay, so it's just a we can say hypothetical gas. Okay, through which we supposed to correlating a behavior of real gas, because as I told you जो भी रियल गैस होता है उसमें कॉम्बिनेशन ऑफ डिफरेंट कॉन्स्टिट्यूएंट रहता है, सो एवरी कॉन्स्टिट्यूएंट हैविंग देयर डिफरेंट प्रेशर टेम्परेचर वॉल्यूम characteristics. Okay, so while what we can say, while monitoring or while estimating performance of that system, we can't we can't concentrate on each and every thermophysical property of that constituent, so it become different complex study. So to make it simple, we are approximating the behavior of real gas with the ideal gas. Okay, and we are treating all the constituent is a ideal gas. Okay, so this is the ideal gas. Now real gas only behave as an ideal gas. Okay, so this statement is also important. Real gas is only behave as a ideal gas or perfect gas at high temperature and low pressure condition. Okay, so जो भी हमारा real gas होता है, real gas means which is exist like air. Real air is a real gas. Okay, because air have a different constituent, different component in that it consists oxygen, nitrogen, argon, sulfur dioxide, nitrogen dioxides, after that water stream. Okay, so a number of component may consist. So जो भी रियल गैस होता है हमारा वो बिहेव करता है आइडल जैसे और परफेक्ट गैस जैसे at a condition of high temperature and low pressure. Means at atmospheric temperature the real gas behave atmospheric temperature and pressure condition, a real gas behave as an ideal gas. Okay, so in simple another word we can say the real gas behave as an ideal gas at high temperature and a low pressure condition. Now fourth one, it only provide approximate behavior of real gas at various temperature, pressure and volume condition. as I told you कि हम ideal gas और perfect gas ये term ये फिलोसॉफी इसलिए यूज करते हैं थर्मोडायनामिक्स में, बिकॉज रियल गैस कंसिस्ट ऑफ n नंबर ऑफ कंस्टिट्यूएंट और n नंबर ऑफ कंपोनेंट इन इट. सो while studying a system we can't concentrate on each and thermophysical property of each and every constant. It become complex study. So to have a simplex one calculation or estimation, we are doing approximate calculation of real gas on the basis of ideal. Okay, so we are treating that real gas is an ideal gas and we are performing a calculation, or whatever the solution are coming or whatever the performance coming out, that after the calculation will be approximate result of a real gas. Okay, now these are the another thing which process inside a ideal or the perfect gas. So molecule move in a rapid and random motion inside the ideal and perfect gas. Molecule moves in a rapid and random motion. Second, molecule feel no attraction, no repulsion. In case of the ideal gas or perfect gas, no molecule feel attraction or the repulsion. Third one, collision between molecules are elastic. Elastic means it collide. There is no any impact force or no any heat generation will take place if impact or collision are take place in between the molecule. After that, volume of actual atom is zero. Okay, volume of actual atom is zero. So this is the what we can say, this is a what behavior of or the properties of the ideal or the perfect gas. So these are those are the properties of our ideal gas. Okay, now we'll see another properties. The physical character of the gases. Those are the physical characteristics of the gases, that is volume, pressure, temperature and the number of atoms or molecules, or we can say it's we can representing as a moles also. So these are the typical units used for the physical prop characteristics of the gases. For the volume, we are using a liter, cubic centimeter, or meter cube. Those are the unit we supposed to use for the volume, for the purpose of calculation of the volume of fluid or a system. Okay, working fluid or the working medium or the system. So 1 liter is nothing. This is a relation of the liter, cubic centimeter, and the meter cube. After that is pressure. Pressure is another characteristic of the gases. For that purpose, we are supposed to use a unit 1 atmospheric pressure. So 1 atmospheric pressure is normally 1.015 into 10 raised to 5 Newton per meter square, or 1 or 10 raised to 5 Pascal. Okay, Newton per meter square or Pascal. After that, another unit we supposed to use for the pressure is kilopascal, bar, okay, gigapascal, megapascal. Okay, so basically we supposed to use a pascal and the bar in thermodynamics to calculate a or to represent a pressure of any system. After that, for temperature we supposed to use a Kelvin. This is a SI unit, all which here discussing. So for the temperature we are supposed to use a Kelvin. Okay. After that, another unit for the temperature is degree Celsius, okay, and Fahrenheit. So normally in case of thermodynamics, we're supposed to use a Kelvin or degree Celsius. After number of atom or molecules, okay, for that purpose we use a mole. 1 mole is equal to 6.022 into 10 raised to 23 atoms or molecule. This is 6.022 is nothing but the Avogadro's constant, which is derived by the scientist Avogadro. Okay, as per the Avogadro, any gases or any substance of 1 mole, okay, have or consist of 6.022 into 10 raised to 23 atoms or molecule in it. Okay, so this is a fixed. All the 1 mole of substance are consist of that much number of atoms. So this is our Avogadro's number. So this is our introduction of the ideal gases and the physical characteristic of the gases. Okay, the next thing we will see the ideal gas law from the next lecture. Thank you.